Welcome all my dear student of FYBSc class. In previous lecture we start second chapter, and in that lecture the second chapter, that is work and energy, we study the work and work done, as well as we also studied the kinetic energy and all the information or all the study regarding kinetic energy. Now in this lecture we are going to see one more important derivation for exam point of view, as well as in this work energy chapter. And the derivation is nothing but, or the article is nothing but, work done during a constant force or work done with a constant force. On this article, question may be asked like this: explain the term work done. Explain the term work done and obtain an expression for work done by a constant force, or explain the term work done, calculate the work done by a constant force. Answer for the half question, first half question, that is explain the term work done, is already discussed in previous lecture. Now in this lecture we are going to obtain an expression for work done by a constant force. First of all, we are going to define the work done by a constant force. What is meant by work done by a constant force? So here student, we can define this term by a very simple way. The work done by a constant force is equal to the magnitude of applied force and displacement of the body in the direction of force. I am again going to repeat. The work done by a constant force is equal to the product of magnitude of force and distance covered by the body in the direction of force. Have you got it? If a force F acting on the body, obviously due to this force body is displaced, or body is displaces through small displacement ds. What I say? If F is the force, why there is a arrow about F? Because force is a vector quantity. And here if this F is the force acting on the body is displaces through a small displacement dx. See here again there is an arrow about ds, because ds is nothing but a small displacement and it is also a vector quantity. So if a force F is acting on the body displaces through a small displacement ds in the direction of force. Suppose here F is the force, and when we apply the force on the body is displaces from this point to this point, and hence ds, vector ds is a small displacement, and this displacement is in the direction of force. Okay. Hence we can write this in a mathematical form: dw, which is a small displacement, which is a small work done for small displacement, and displacement is taken in the direction of force, and hence it is defined as the work done is equal to the magnitude of force, that is mod of F and magnitude of displacement, that is mod of ds. Hence we can write here F, magnitude of force is nothing but F, and magnitude of displacement is nothing but ds. Suppose this is equation 1. Okay. This is the small work done for a small displacement. Now we are going to calculate total work done for total displacement, that is from this point to this point, and that is nothing but total displacement is S, and this displacement is due to the force F acting on the body. Okay. And displacement is also takes place in the direction of force. So how we can obtain total work done mathematically? For that purpose we have to integrate this equation 1, and after integrating the equation 1 we get integration of dw is w, and integration of this term f ds. Okay. Suppose this is equation 2. You know that during the entire displacement the force is constant. संपूर्ण डिस्प्लेसमेंट होत असताना फोर्स हा कसा आहे कॉन्स्टंट आहे. म्हणूनच आपल्या आर्टिकलचं टायटलच आहे वर्क डन विथ कॉन्स्टंट फोर्स. सिन्स द फोर्स रिमेन्स कॉन्स्टंट ड्यूरिंग द टोटल डिस्प्लेसमेंट यस, that means from this point to this point, the equation 2 may be written like this: w is equal to f. F is constant, so take it out of the integration ds. Okay. Suppose this is equation 3. Now if constant force, this constant force is acting on the body, is along the direction making an angle theta with the direction of displacement, then work done by the displacement by a constant force is obtained by resolving the force F into two rectangular components. That is, one of them is Fx and another is Fy. What I say, I am going to repeat once again. If a force acting on this block or on this body, and due to this force the body is displaced in the direction of force. Okay. Now when the body is displaced along the direction of force, a direction making an angle theta, okay, with the direction of displacement ds, this is okay. Hence the work done by a constant force which displaces the body in the direction of force is obtained by resolving. म्हणजे आपण आता फोर्स काय करणार, रिझॉल्व करणार दोन कंपोनेंट मध्ये. वन ऑफ देम इज Fx and another is Fy. Note that Fx, this component is in the direction of displacement, and this component Fy is perpendicular to the direction of displacement. Okay. So the magnitude of two components are given like this: Fx, and this Fx is along the direction of displacement ds. Fx is along the displacement dx, such that Fx is equal to Fx cos theta, or simply F cos theta. Fx is F cos theta, that is in the direction. And second component Fy, and this component Fy along the direction perpendicular to the displacement ds. बघा आता हा जो कंपोनेंट आहे हा फोर्स रिझॉल्व केला आपण दोन कंपोनेंट मध्ये, एक असणारी Fy, दुसरा असणारी Fx आणि दुसरा असणारी Fy. Fy कसा आहे, हा कंपोनेंट ज्या डिरेक्शनने डिस्प्लेसमेंट होती त्या डिरेक्शनला तो पॅरलल आहे. दुसरा कंपोनेंट आहे तो कसा असणार, ज्या डिरेक्शनने डिस्प्लेसमेंट होती त्याला तो परपेंडिक्युलर असणार आहे. ओके. आता इथं होतं काय की हा जो कंपोनंट असणार आहे सेकंड कंपोनंट याचा इफेक्ट 0 असणार आहे का since the body does not move in this direction, body is moving in the direction of force. Therefore here we can say that since the body does not move along the component of Fy, so Fy does not work on the body. You got it? What I say? As the body does not move in the direction of component Fy, and hence Fy does not work on the body. Okay, so the work done by the component Fx only. See here, Fy is equal to F sin theta. This is another component which is perpendicular to the direction of displacement, but this component does not work on the body. Why? Because body does not move along the direction of component Fy, and hence only this component is effective, this component is not effective, this component does not work on the body. Okay, only this component works on the body. Therefore the work done by the component dw is the work done by the component Fx is dw is equal to F cos theta. Okay. Or simply we can say that Fx ds, Fx dx. But here we can say that dw as we know that what before that Fx is equal to F cos theta. This is the effective component. Therefore we can write dw is equal to F cos theta ds or F ds cos theta. Now instead of this we can write F into ds vector F dot vector ds, because we already studied in 12th science and in previous lecture also vector F, that is force, and another quantity ds. These two quantity are vector quantity, and when we take the dot product of these two quantity we get F ds cos theta, where F is the magnitude of this force and ds is the magnitude of this displacement, and theta is the angle between these two vector quantity, and hence we can write dw is equal to same vector F dot vector ds. This is the work done, small work done for small displacement. Now the work done during finite displacement, this is infinitesimal displacement, this is the infinitesimal displacement or very small displacement, and this is the finite displacement. Here for this infinitesimal displacement the work done is dw is equal to vector F dot vector ds, and in order to obtain the work done for finite displacement, what we have to do? We have to integrate this equation. Suppose this equation is number 4. When we integrating this equation, we can write dw is equal to integral vector F dot vector ds. Again F remains constant during the entire displacement. इथून तर इथपर्यंत, या पोझिशन पासून या पोझिशन पर्यंत डिस्प्लेसमेंट होत असते, फोर्स आपण अप्लाय करतो, पण इथं फायनाईट डिस्प्लेसमेंट ज्यावेळेस घडते तर एंटायर डिस्प्लेसमेंटला फोर्स कसा असणार आहे? कॉन्स्टंट. वर्क डन जे आपल्याला ऑब्टेन करायचे, कसं ऑब्टेन करायचे? वर्क डन ऑब्टेन और वर्क डन विथ a constant force. So if this force is constant, then here again we can write integral dw is nothing but w and f into vector ds. आपण हा बाहेर का घेतला वेक्टर घ्या? बिकॉज रिमेन हा कॉन्स्टंट असल्यामुळे इंटिग्रेशनच्या बाहेर येईल. नाउ सॉल्व दिस. वी हॅव वेक्टर f dot vector s. where S is the integral of ds. Okay. Therefore, this is the total work done for the entire displacement. From this, suppose this is equation, this is 5 and this is 6. From equation 6, we can write W is equal to Fs cos theta. Once again, here F is a vector quantity, force vector quantity, and vector S, that is displacement, is also vector quantity. And when we take the dot product or scalar product of these two vector quantity, then we have Fs cos theta, where F is the magnitude of vector F and S is the magnitude of vector S, and theta is the angle between these two vectors. Okay. So here equation 6, that is W work done, total work done for entire displacement is Fs cos theta, is very important expression, and this expression gives the work done with a constant force. Hence, the work done by a constant force may be defined as the dot product, these are this, the dot product, this means this and this, the dot product or scalar product of applied force and the displacement. I am again going to repeat. दुसऱ्या जसं आपण पहिल्या सुरुवातीला डेफिनेशन बघितली ॲट द व्हेरी बिगिनिंग ऑफ दिस लेक्चर, तसेच आपण आता दुसरी डेफिनेशन अशी करू शकतो याच्यावरून की जसं आपण म्हटलंय ॲट द बिगिनिंग ऑफ द लेक्चर, द वर्क डन ड्यूरिंग ए कॉन्स्टंट फोर्स इज द प्रोडक्ट ऑफ magnitude of force and displacement in the direction of force. That is the definition of work done during a constant force or work done by a force. Now from this we may define the same definition like this. The work done may be defined as the dot product or scalar product of applied force and the displacement produced by the force. Okay. Now from this equation 7, here 7, from this equation 7, it is clear that the amount of work done by a constant force depends only on ending point. बघा या इक्वेशन 7 वरून काय क्लिअर होतं आपल्याला, आणि या फिगर वरून वर्क डन जे असेल कॉन्स्टंट फोर्स असताना जे वर्क डन होईल ते फक्त कशावर डिपेंड असतात, एंडिंग पॉईंटवर, कुठून स्टार्ट होणार कुठे संपणार, कुठे स्टार्ट होईल आणि कुठे एंड होईल, या दोन एंडिंग पॉईंटवरच हे वर्क डन बाय ए कॉन्स्टंट फोर्स डिपेंड असतं. म्हणून मी म्हटलं इथं फ्रॉम दिस इक्वेशन इट इज क्लिअर दॅट द अमाऊंट ऑफ वर्क डन बाय ए कॉन्स्टंट फोर्स डिपेंड्स ओनली ऑन द एंड पोझिशन अँड नॉट ऑन द इंटरमिजिएट पाथ. हा लक्षात, समजा हा पाथ असा असेल किंवा हा पाथ असा असेल, दॅट डझंट मॅटर, इंटरमिजिएट पाथ हा मॅटर करत नाही. तर वर्क डन बाय ए कॉन्स्टंट फोर्स कशावर डिपेंड असतं, फक्त एंड पोझिशन, दॅट्स मीन्स दिस पोझिशन अँड दिस पोझिशन. ओके, आर यू गॉट इट? द वर्क डन, सपोज दिस बॉडी स्टार्ट टू मूव फ्रॉम दिस पॉइंट by this way and come back by this track to its original position. That's why this is a round trip, and during the round trip the work done is 0. लक्षात घ्या, राऊंड ट्रिप जर तिथं डिस्प्लेसमेंट असेल म्हणजे इथून तर इथपर्यंत या पाथने, आणि दुसरा हा सेकंड पाथ असेल, दिस इज फर्स्ट पाथ अँड दिस इज सेकंड पाथ, आणि जेव्हा अशी राऊंड ट्रिप होते तेव्हा वर्क डन कसं असणार आहे, 0. बट वन थिंग इज व्हेरी इम्पॉर्टंट अँड यू हॅव टू कीप दिस थिंग इन युअर माइंड फॉर एव्हर. दो द वर्क डन ड्युरिंग राऊंड ट्रिप इज 0, but work done on the body is never 0. Okay, so what is the example? The work done by gravitational force in moving the bodies near the earth surface is an example of this case, which is The example what I say, work done by the gravitational force in moving the bodies near the earth surface is the example, best example of this or of this type of force. Now I am going to give some illustrations, and that illustrations are very important to decide whether the constant force is positive or negative or zero. Okay. So first illustration. First illustration, see here. From equation 7, from this equation, the work done by constant force, हे जे वर्क डन होतं या कॉन्स्टंट फोर्स कडून, the work done by a constant force, this work done may be positive, may be negative or may be zero. There are three cases. There are three illustrations. How? So first, suppose this force F and this displacement. Suppose this is the force and this is the displacement. If both the quantities are in the same direction, म्हणजे ज्या डिरेक्शन डिस्प्लेसमेंट होते त्या डिरेक्शनने फोर्स ऍक्ट होतो किंवा ज्या डिरेक्शनने फोर्स ऍक्ट होतो त्या डिरेक्शनने डिस्प्लेसमेंट होते, असं जर असेल तर या दोन क्वांटिटी मध्ये जो अँगल असेल थीटा, दॅट इज इक्वल टू 0. This is the first illustration. In this illustration, if vector F and vector S or ds are in the same direction, what happen? Angle between them is 0, that is theta is equal to 0. And when theta is equal to 0, from this equation W is equal to F S cos 0. And we know that what is value of cos 0? Cos 0 is equal to 1, therefore W is equal to F S. Here the work done by the force on the body is positive. The work done by the force, constant force acting on the body is positive. What will be the example of this type? When a body falls freely under the gravitational force. What I say, when suppose this is a body and I release this body, what happen? A body falls freely under the gravitational force and the work done by the gravitational force is positive. लक्षात आलं? हा डस्टर मी इथून रिलीज केला तर तो काय होणार आहे? दिस डस्टर फॉल्स फ्रीली अंडर द ग्रॅव्हिटेशनल फोर्स and the work done by the gravitational force is positive. Okay. Now second illustration. In second illustration, if suppose this is the force and this is the displacement, if F and S, this is the displacement, F and S are perpendicular to each other. Again here, suppose this is the displacement and this is the force and there is angle between them is 90 degree. That means these two vector quantity are perpendicular to each other. Angle between them theta is equal to 90 degree. When theta is 90 degree, again from equation 7, W is equal to F S cos 90 degree. And what is the value of cos 90 degree? Is 0. Cos 90 is equal to 0. When we substitute this value 0 into here, therefore W is equal to F S into 0 and finally F is equal to 0. If the body moves perpendicular to the direction of the force, obviously the work is 0 or work done is 0. I am going to tell you one of the best example. When a coolie moves on a railway platform with a load on his head, then work done by the coolie is 0. ज्या वेळेस एखादा कुली रेल्वे प्लॅटफॉर्मवर त्याच्या डोक्यावर लोड घेऊन चालत असेल, आपल्याला माहिती लोड कसा होतो, एक्झिट होतो, फोर्स कसा आपला होतो असा, आणि लोड कसा आहे असा परपेंडिक्युलर. म्हणजेच आता फोर्स कंपोनंट कसा आहे Fy आणि डिस्प्लेसमेंट कशी त्याची अशी असेल. हे दोन्ही कसे असेल, फोर्स ग्रॅव्हिटेशनल फोर्स आणि डिस्प्लेसमेंट आर परपेंडिक्युलर टू इच अदर. त्यांच्यामध्ये अँगल कसा असणार आहे 90 डिग्री असेल. ज्यावेळेस 90 डिग्री असेल, थिटा हा 90 डिग्री असेल, तर त्यावेळेस ऑब्विसली जर आपण इथे ती व्हॅल्यू टाकली cos 90 तर आपल्याला मिळणारी cos 90 0, आणि cos 90 0 असेल तर याचा अर्थ W इज इक्वल टू 0. आणि म्हणून दिस इज द बेस्ट एक्झाम्पल when a coolie moves on a railway platform with a load on his head. At that time work done by the coolie is 0. Okay, now third illustration, when suppose this is the direction of force and this is the direction of displacement. Let's be short, here vector F and vector S are opposite to each other. Vector is moving, force is acted in the direction of displacement, body is displaced in this direction. Then W, from this equation W is equal to F S cos pi. That is, see here, दिस इज द डिरेक्शन ऑफ एस. आता ह्या दोन डिरेक्शन कशा आहे, एकमेकाला अपोजिट आहे, म्हणजे त्यांच्यामध्ये अँगल किती असणार आहे 180 म्हणजेच पाय इज इक्वल टू 180 डिग्री. मग जर समजा दोन्ही वेक्टर क्वांटिटी एफ अँड डिस्प्लेसमेंट आहे ह्या अपोजिट असतील, त्यांची डिरेक्शन अपोजिट असेल, तर त्यावेळेस इक्वेशन 7 वरून आपण लिहू शकतो W इज इक्वल टू एफ एस कॉस पाय, आणि व्हॅल्यू ऑफ कॉस पाय इज नथिंग बट -1. मग जर ही -1 इथं सबस्टिट्यूट केली तर आपल्याला W इज इक्वल टू एफ एस इंटू -1 और W इज इक्वल टू एफ एस. नाउ फ्रॉम दिस इक्वेशन इट इज क्लियर दैट द वर्क डन बाय द फोर्स एक्टिंग ऑन द बॉडी इज नेगेटिव. ओके, हियर I am going to tell you the best example when suppose this is a positive charge Q. And this positive charge Q is moved towards another positive charge Q. What happen? Electrostatic force exists between two charges. See once again, when the first charge, positive charge Q, is moved towards another positive charge or vice versa, then work done by the electrostatic force. इथं दोन्ही मध्ये काय असणार आहे इलेक्ट्रोस्टॅटिक फोर्स. हा पॉझिटिव्ह चार्ज या पॉझिटिव्ह चार्जकडे येतो, हा पॉझिटिव्ह चार्ज या पॉझिटिव्ह चार्जकडे मूव्ह होतो, तेव्हा त्यांच्यामध्ये कोणता फोर्स होतो इलेक्ट्रोस्टॅटिक फोर्स. आणि हा इलेक्ट्रोस्टॅटिक फोर्स जो असेल तो काय करणार आहे वर्क डन इथं घडून आणेल. अँड द वर्क डन बाय द इलेक्ट्रोस्टॅटिक फोर्स बिटवीन टू चार्जेस इज निगेटिव्ह. ओके, the work done by the two electrostatic charges between work done by this electrostatic force between two charges is negative. Though the work done between two charges is negative, but one should be very important thing, you have to keep that thing in your mind forever, that is it must be noted that work done by the applied force is always positive. जरी ह्या दोन मध्ये इलेक्ट्रोस्टॅटिक फोर्स हा निगेटिव्ह वर्क डन करत असेल, परंतु ज्यावेळेस ही बॉडी कुठलीही बॉडी ज्यावेळेस फोर्स वर्क डन बाय द अप्लाइड फोर्स ऑन दॅट बॉडी इज ऑलवेज पॉझिटिव्ह. ओके, इन दिस वे वी स्टडी हियर or we obtain the expression for work done by a constant force, and I explain all these things or work done with all three illustration with suitable example. Okay, in next lecture we will see the work done by varying force, that is spring force, and this article is also very important, which will be study in the next lecture. Till then, we shall stop here. Have a good day.